Hi there, guys. I'm just going to go through the complex number examples before 8D in the exercise. So we're looking at example 5 and example 6. Now, in example 5, if you click on the calculator, you get options here. So let's click on this one here, and you've got either the TI Inspire or the other calculators, which they give you options for. For some reason that's disappeared. So there we go. So this opens up and gives you the instructions for the TI Inspire for doing all of your complex number calculations on your calculator. And if you don't know already how to store things as different variables on your calculator, then it's really useful to know that if you press Control and Variable, then it gives you the store option. So for example, they're saying here, put in the complex number 2 plus 3i, and then press Control and Var, and that will give you the option to store. So it will give you an arrow, and it suggests that you use a capital letter A here, but it's fine to use the lowercase a. In fact, it's showing you the lowercase a here as well. You can get capitals by doing Control and Shift and then A, but we're not required to have capitals for these complex numbers. Okay, once you've done that, you can follow through all of the calculations from that question. However, what I'm going to do is slightly longer, and I'm going to show you here just how to do these calculations by hand. So this is going to take quite a bit more time, and obviously you can skip this if you want to just by doing all of these things on your calculator, but a lot of people will want to know how these things work. If you do skip it, then I suggest you go and look at go to later in the video and have a look at example 6, because there's a little bit of theory that I'm going to go through before doing that question. Okay, so example 5, we have 2 plus 3i and 3 minus i as our two complex numbers here. And it says calculate each of the following, writing your answers in this form here. So in rectangular form, this is called, or Cartesian form. You'll notice on your calculator, by the way, that you need to have your calculator set up to deal with complex numbers. And in terms of it being set up, you need to go to Document Settings, and you want to go to change the mode to rectangular. Okay, so that's important. And also, if you want to write I, then you can't use the keyboard at the bottom. You need to go to where it says pi, and then this kind of little arrow. So the pi key gives you the option to choose this sort of bold version of I, which of course we understand is the square root of -1. Okay, so calculate each of the following. So in this one, that's pretty straightforward. So for I here, A part I, we've got 2 lots of Z1. So all we need to do there is double each of those things. 6i there. And we don't need an underline, by the way. You might know about I underline being equal to your unit vector, 1 in a horizontal direction, movement of 1 in the horizontal direction there. But these are not vectors, of course. This is just the imaginary part of our number. So the I without an underline is just equal to square root of -1. Okay, so that's 2 lots of Z1, and of course we need here 3 lots of Z2. So that's 9, and then minus 3i there. And of course, you can put that together just like normal algebra. So we've got 13 and plus 3i. Okay, so this one is done. Okay, so for the next one, take this. So Z1 is going to be, again, 2 plus 3i. And Z2 is 3 minus I. So we're just timesing these two things together. 2 times 3 is going to give you the 6. 2 times minus I is minus 2i. And these two times together gives us plus 9i. And then we're getting these two times together. So the 3 times the -1 gives us -3. The I times I is the same as doing I squared. And I is the square root of -1. So when we square that, we get -1. Okay, so I've got I squared there. That I squared is going to turn into -1. So essentially that's going to be +3 there. Okay, so now we've got 6 plus 3 is 9, and we've got 7i there as well. So that's a part 2 done. The only complicated thing there is doing this times this. Remember, when you times I by I, that's going to give you -1. So seeing as we already have 1 minus there, that's going to change the 3 into a +3. -3 into a +3. Okay, let's just check that one. So check those two answers, of course. So we've got 9 plus 7i and 13 plus 3i. Okay, so now it gets a little bit more complicated by hand to do the third one. So for a part 3 here, you've got these two added together on top. So that's going to give us 5 and plus 2i on top. And on the bottom, we're going to have this take away this. That's going to give us -1 there. And take away minus I is going to give us plus 4i. Okay, so that's what we've got on the bottom. Now, this is a bit like when you end up with something like 1 over the square root of 2. We agree to write this in mathematics as square root of 2 over 2. We don't like to have the square roots on our denominators with surds. Now, we don't like to have complex numbers on our denominators here when we're doing a division of complex numbers, or even if you just had 1 over a complex number on the bottom, we wouldn't like to have that. In fact, they want us to write the answer in this form here, so they don't want this complex number on the bottom. Okay, well, we can't simply do 2 divided by 4 there because to leave a 2 on the bottom, because of course 2 isn't a factor of the top and the bottom here. So very similar to working with surds, where we rationalize the denominator. Here we're going to make the denominator a real number by timesing by the complex conjugate here. So in this case, what we're going to do is times this one by -1 and then -4i. Okay, and so that's the normal thing that we would be doing there. That's the complex conjugate of this thing here. Now, it might also be possible to times this one by 1 plus 4i as well here. However, I'm going to keep it really standard because this is the complex conjugate. All I need to do is change the sign in front of this part here. So I'm going to keep this straightforward, follow the basic technique. Now, if we times by 1 over this, obviously it's going to change the number. So we're going to need to times by the same thing with the same thing there. So we're essentially timesing by 1. Okay, this is just 1. So now we've got 2 multiplications which we need to do, and that's obviously going to take a bit of time. So we're getting on the top -5 and 5 times -4i, so -20i, and then we're getting 2i times by -1, so that's -2i there, and then we're doing this times this, which is going to give us 8, make it a +8. Of course, we've got I times I there as well, giving us -1. And on the bottom here, we can see we've got -1 times -1 is +1. -1 times -4i gives us +4i. And then these two times together is -4i. So we can see that these two are going to disappear. The imaginary parts are going to go. And these two times together here is 16. So it's +16 there because, of course, we've got I times I is -1 as well. So we can finish this then by saying -5 plus 8 on the top gives us 3. That's -22i, and that's divided by 17. This is going to cancel. Now, put it in this form here. We're then going to need to say we've got 3 over 17 minus 22 over 17i. And now we've got it in the form which we want. Okay, so the way in which we deal with this question is to times the top and the bottom, the numerator and the denominator, by the complex conjugate of the denominator. Okay, so let's just check that answer. Let's hope we got that one right. Yeah, okay, and you can see they've not put it in the form that they've asked for here. I would split that up in terms of 3/17 and minus 22/17. They've put no conditions on A and B, by the way, but I'm assuming that A and B are real numbers, so they're allowed to be fractions, of course. Okay, so for part B in this question, for part B, we're looking at saying if the imaginary number here, the imaginary part of these two complex numbers added together is equal to 0, then find P. Okay, so let's just add these two things together to start off with. Let's come up with an expression for that. So we're looking for B, we're looking for the imaginary part of this plus P lots of this. So we're going to get 2 plus 3P as our real part. And then we're going to get plus 3 and then minus P lots of I as our imaginary part. Okay, so all I've done there is I've times this by P, so that's 3P minus PI, and I've taken that away from this thing here. So, no, I've not, that's not true, I've added. So 2 plus 3P, what I got there, and 3I plus minus PI gives us 3 minus PI. So I've kind of factorized that one. Okay, so the imaginary part of this is equal to 0, but the imaginary part is just this bit here. So it's just 3 minus P. So it's the size of the coefficient of I. So, and that's giving us 0. And so then we can see that we've got P is equal to 3 here. Okay, let's just check again the working out in the book for that one. And they've said here the imaginary part is 0, therefore 3 minus P is equal to 0, therefore P is equal to 3. Just checking through some of the definitions here. Yeah, so when it talks about the real part of A plus BI is equal to A, so that's in the middle here, and it says the imaginary part, A plus BI, is B. It's not BI, it's just the B. It's the coefficient of I. Okay, so then let's look at example 6. So let's take this one here. So example 6 says one solution of this equation is 2 minus 3i. Find the value of P and the value of Q. Okay, well, actually, I'm going to come up with a little example here, and I'm just going to say if we started with the equation x squared plus x plus 1 is equal to 0, then if we were going to apply your quadratic equation solver, you'd get minus b, so minus 1, plus minus b squared, which is going to be 1, minus 4ac, okay, so 4 times 1 times 1, divided by 2a, so that's just divided by 2. And that's going to be your solution for x. Now, when you get that solution for x, you'll get minus a half, so that's just this part here, and then plus or minus, and inside here we're getting the square root of minus 3 divided by the 2, because we're dividing by the 2 on the bottom as well. Okay, so from the quadratic formula, you can see that you're always going to get two solutions in the form of a real part and this imaginary part here. So that's minus a half plus minus. Now this is really square root of minus 3. It's the same as doing square root of minus 1 times by the square root of 3. That's just working with our rules of surds. So we can say that this is square root of 3 lots of I. Okay, so I is square root of minus 1. So on the top here we have square root of 3 lots of I. We're dividing that by 2. I'm just going to write this as a fraction here. I can put the I over to the side. Okay, I've essentially just factorized out this square root of minus 1, which is I. So you can see that we're always going to get this format here. So if we get one solution is 2 minus 3i, then the other solution which we're missing is the plus version. So the other solution should be 3 plus 3i. So we're always getting these solutions, these complex solutions in pairs, as shown by through the quadratic formula. Okay, so let's just see what the question is saying. It says one solution of this equation is this. Find the value of P and the value of Q. So if I was to factorize this, then I'd have X minus this thing here. And the other solution is going to be X plus. X minus, sorry, the other solution is X minus 2 plus 3i. Because those are your two solutions there. Think about that one. If I said X minus 1 and X minus 2 was my factorization, and that's equal to 0, then we'd quite easily see that X is equal to 1 and X is equal to 2 as our two solutions. So all I've done is I've put in one solution here, where there we've got 1. And I've put the other solution, which is this, which comes from considering the plus or minus that imaginary part. Put that other solution in here, is X minus that solution there. Now, if I put in X is this in here, I'll get a 0 from this bracket. And if I put X is this into here, then I'll get a 0 out on this side as well. Okay, so that's the factorization. Okay, that's our factorization of this quadratic here, given that we've been told that that's one of our solutions and that we can find the other solution by doing plus or minus the imaginary part. Okay, so it says find the value of P and the value of Q. Well, what I'd do now is multiply this out in order to get this expression here, and then I'd compare those two expressions. So we've got here the fact that we've got x squared, x times x, we've got x times this, so we're getting minus x 2 plus 3i, and we're getting x times this, which is minus x times 2 minus 3i, and then of course we're getting this times this as well, so we're getting there plus 2 minus 3i, 3 plus 3i. And you'll notice here that this is the complex conjugate of this, so your imaginary parts are going to disappear. Now, we can still say that's equal to 0. Frankly, it's just this thing here, really, which is the same. So I'm actually going to say now we've got x squared plus px plus q has to be the same as this thing here. It has to be identical to. That is to say, we've got the same amount of x squareds, the same amount of x's, and the same amount of this constant term as well. They all have to be the same. So now I can see on this side, I can combine this and this essentially, these two terms here. Say we've got on this side, we have x squared, and then we have, we can multiply this out, of course, and we'll get minus 4 lots of x, and we've got minus, so we have here minus 3i times by x, but also a plus 3i times by x from this one. So that's going to disappear. And then when we multiply this one out, we'll get, so that's going to give us 4. Okay, so this times this. The two middle terms are going to disappear, and then we'll get this times this, which will give us plus 9 there. Okay, 3 times 3 is 9, but then we have a minus here, so that's a minus 9. I times I is minus 1. Okay, so finally, we can say that this is x squared minus 4x, and then plus 13 there. So we can see, therefore, that P is equal to minus 4, and Q is equal to 13. Okay, so the question is done. Let's have a little look at how they do that one in the book. They do it in the same way. Okay, so same setup there, and hopefully I've given the explanation for that as well. You can have a look back through. There's an investigation there. Of course, investigation is always good to do to hone your skills for those extension questions on the extended question paper 3. So they're always useful to do. There's a couple of investigations there. They talk about. Let's just take this and take these couple of boxes here. In fact, they talk about the discriminant here. Discriminant is this thing here. It's just the thing which comes inside your quadratic formula. So it just comes from the quadratic formula here. So this is the discriminant, and we can obviously see that when the discriminant is greater than 0, then we'll have plus or minus something or other over here. If the discriminant is equal to 0, then there will be no plus or minus anything, and therefore we'll end up with one real solution. Most of you will have done this before when we've dealt with quadratics. And of course, if this is negative, we'll have the square root of a negative number. The square root of a negative number is a complex number. In fact, will be an imaginary number. So there will just be an imaginary part to this solution here. So if the discriminant is less than 0, then we have no real roots, but we'll have 2 complex roots. So further down here as well, it's talking about complex numbers divided into 2 parts. And again, it's got a real part and an imaginary part. And B here is representing our imaginary part. How much of I do we have here? How imaginary is this number? Okay, and the conjugate, as what we've talked about, is that you have just whatever you've got here. So that could be, say, for example, 2 minus 3i. The conjugate would be 2 plus 3i. You just change the sign here. And the useful thing for that is if you times those 2 things together, you'll eradicate the complex part or the imaginary part of that number. Okay, right, that's done. In the next video, I will look at the examples before the next exercise. And so this is 8D. In 8E, there's a bit more to deal with here, and it goes a little bit further than the original videos which I showed you from the AA course, which I made up, because they start talking about polar form here as well. So there's going to be some extensions to this. Okay, thanks for listening, guys, and good luck with the exercise.